Great, well thank you everybody. Certainly an honor here to kick off the morning. Hopefully you have your coffee and ready to get moving. So as previously stated, I'm Brad Martin, Chief Operating Officer at Senet. I'm going to speak to you about what Senet does and specifically what the LoRa technology, the LoRa Alliance are all about, and hopefully answer any questions you have. This is intended to be pretty interactive, so don't hesitate to step in anytime you have questions. Don't hesitate to ask, and we'll put hands up and we'll try to get them answered as quickly as possible. So at a high-level perspective, I guess Senet is a low-power wide area network service provider for North America. And I'm going to go into some of the technologies here and what is LPWAN as compared to the other wireless protocols that are out there on the market. We're headquartered right here in Portsmouth, New Hampshire. We're a startup company. We have a few more than 43, about 46, 47 employees. So we're pushing about 50 employees. We have the largest LoRaWAN network, largest LPWAN network in the United States. It shows you how early this technology is, certainly here in North America. In that network today, we have about 225 municipalities throughout the United States and about 23 states, covering about 50 million people in total population. As I mentioned, we are the first and the fastest growing LPWA provider in the United States. And we are explicitly the first live LoRaWAN network within North America. And Senet is a very engaged and active participant in the LoRa Alliance. And we were very early, we were one of the founding members, we're very early in the technology. And we'll go through, we've actually been very active both in the Alliance marketing, standards boards, the technical committees. Our CTO, our CEO of Senet have been very, very engaged with that and have helped really formulate the standard. But LoRa, we'll get into more detail, is an open standards alliance for low power wide area network, and we'll get into a lot more detail about that. So to step back, what are the different options for wireless connectivity? And there's a lot of different technologies out there, and this really kind of bridge across standard Wi-Fi local area networks. Again, these has lots of great benefits. My background is data communications. Came from a Wi-Fi company. Very familiar with the technologies. Really good for a lot of different elements. But this is Wi-Fi, Bluetooth, Zigbee. Standards have been around for quite some time. Ultimately, short range, very well established standards around Wi-Fi. They're very good for high data rate, very accessible, pretty pervasive throughout the world. It's not very good for really long range. That's one of the downsides on Wi-Fi. Then in the middle, you have cellular networks. This is traditional cellular. So 3G, 4G, LTMs, GSM. This is a really important market. It's obviously very well established, been around for a long time, well built, very much, lots of great competition. It's designed for this. Look. Okay. The cellular networks are designed for this, right? It's designed for humans to communicate. And this is really where LPWA comes into play. Low power wire network is really intended for machine-to-machine communications. And that's where you'll see some predicted total addressable market opportunities here from some analysts, but it's projected that LPWA, and there are several different technologies within LTWA that will take up quite a bit of the overall machine-to-machine communication market here over the coming years. But very, very long range, so low power wide area, what is it? It's low power, it's really low cost. Machines say very few things for the most part. Machines say little bits of information, I'm on, I'm off. Here's my operating profile for the last 8 hours. We provide a very, very low cost, very, very long range capability to be able to connect up your machine-to-machine communication. Again, you can see what they're good for. You're never going to have a cell phone connect, a phone call over our network. We're not competing at that level, but the smartphones have really driven the existing networks on the cellular side to a level which is critical because we need cell phones to do business. We need smartphones to be able to manage ourselves. Low power wide area network is really that step down for really cost-effective machine-to-machine communication. Any questions on these? Yeah.
When you say long range, like what's the distance?
Yeah, great question. So we'll get that in a slide coming up here, but I'll give you a little bit of some detail there. So in general, everyone's pretty familiar with Wi-Fi. Everyone has Wi-Fi in their homes. Again, there are different types of Wi-Fi and other standards in the local area network space. It's relatively small range. Cellular, cellular, you see towers everywhere. In general, 3 to 5 miles is about the transmission radius on a cellular network. low power wide area network for a similar application for open air urban deployments and rural deployments. It can be anywhere between 10 to 15 miles per gateway. So it's a pretty significant difference. And we have, I'll go into some detail later on in the presentation here, we have an application called EnterTrack. It's a tank monitoring solution we use for propane energy marketers throughout the country. And we have, every day we have devices reporting in at 25, 35 miles. Our longest transmission was actually right here in New England. We used to have a tower on Nantucket Island. We first did that tower, but picked up a device on Long Island 110 miles away. We never plan a network with that type of distance. So our planning range is typically that 10 to 15 mile range, but you get tremendous amount of coverage. And it's RF, so it's line of sight, it's the level of clarity in those areas. So in urban areas, more noise, floor level is a little bit noisier. Our planning radius is 3 to 5 miles, where cellular is probably a quarter mile within the city. So it's double to triple the overall range in the cellular, the traditional cellular networks.
Fred, a question over here.
Oh, sorry, go ahead.
Okay.
So I'm curious about inside a building, a steel building, for instance.
Yep.
What kind of range you get?
Yeah, that's a great question. So one of the key standards for, specifically for LoRa, I'll get into more data on LoRa and some of the competitive differentiators, it's sub-gigahertz. So you may be familiar with Wi-Fi 2.4, 5 gigahertz. Again, very, very high bandwidth for very high data load. We're sub-gigahertz. We actually use the ISM band. So this is the Industrial Scientific Medical Band. This is free open spectrum from the US government. Part of the reason why we can get very, very low cost of overall data transmission. So Wi-Fi, very good for indoor. You know, again, Wi-Fi company was my last business. It struggles getting through certain building materials. Sub-gigahertz does a lot better job getting into buildings. Metal is a problem with RF. Faraday cages will prevent RF from getting in. So you have to make sure you're planning, you understand what your building infrastructure is. But basically, you're getting through, standard glass. Treated windows does a much, much better job than Wi-Fi. So it does a pretty good job. We certainly have tremendous capability getting through concrete, even still reinforced concrete. We have many examples of our devices deployed for smart building technologies on a first floor data closet. It's getting 4 levels down through a parking garage into a basement closet through significant levels of construction where your Wi-Fi just wouldn't be able to get that. So it does have very, very good penetration to construction material in general, but solid metal cage is still going to be a problem. So I won't go through the next slide in a tremendous amount of detail. I think, will these slides be made available after?
Yes.
Okay, so you feel free to look into this. There are multiple different technologies here in the LPWA space. And so there are a couple of competing technologies, Ingenue, Sigfox. These are true low power wide area network solutions. There are several developing standards coming out of the big cellular carriers. One of those is LTE-M, the other is NB-IoT. We feel very strongly that LoRa is the premier solution here. In fact, Senet, a few years ago, we went through and we had an application with thousands of nodes deployed, and we wanted to revamp that application, the technology at the communication layer. We went through and actually went through the entire market and said, what's out there? What's available to us to deploy our technology? And we went through the check boxes on each of the technologies, and we selected LoRa in that effort. And you can see some of the competitive variation. This is our perspective on this, and you'll see plenty of charts in this space. But ultimately, from a cost perspective, the payload of the data, the ability to manipulate and mitigate noise in that ISM band, very important. LoRa has some unique capabilities in that space which allow for cost-effective communications to take place.
You've got security down as the second item.
That's
One
right.
of the biggest problems we have is having a building automation system or having any kind of sensing, any kind of data collection on our client's network.
Yep.
Whether it's high tech, whether it's finance, this really kills a lot of energy projects, kills
Absolutely.
a lot of analytics. Could you speak a little bit about the security?
Yeah, absolutely. And it's a great question, important topic that we obviously has a lot of interest recently with the attacks 2 weeks ago through an endpoint and an unsecured end node. So security. So from a transport layer, the LoRa technology uses the latest encryption standards. So from a transport layer, your data is as secure as it could possibly be. What really takes place and what's important is, as you guys know, network design. Making sure you have your network designed appropriately, making sure there's proper provisions for securities for different types of endpoints. The endpoint security is really what is very important. Making sure that you are utilizing the proper endpoints on your network depending on the security level that you want. So whether it be a FIPS, actually FIPS certified endpoint, that was one of the problems recently with the IP camera attack, was you had an unsecured end node which came onto a network which propagated that denial of service attack. So from a security perspective, Senet with LoRa utilizes, again, the latest and greatest encryption standards, but security, is holistic. It's the entire network view. From the other technologies, they use some proprietary standards for security, or non-standard security approaches. Key differentiation on security from Senet perspective is we are using IEEE standards for encryption. And some of these others are utilizing either a more custom or non-standard security approach, but some are using similar encryption methodologies that we're using as well. But absolutely, security is paramount in overall application planning, network planning, and we, from a network perspective, take it to the highest level that we can possibly take it. Question?
If you were picking up pulses from a utility meter at the entrance to the facility, would it be cost effective just to pick up a certain point? And it seems like that security level, would anybody even be concerned about it? If it was just a pulse off a utility meter going on to this?
So utility meters are actually an application that we're involved with right now. So again, it depends on, but from a security perspective, it really depends on the securitization of that packet, and again, the transport layer securitization. And again, we're using the latest IEEE standards for encryption, and that's a very encrypted packet really from the source. And I think something that's pretty unique about the Senet network and even LoRa is you can pass that packet fully encrypted all the way to the destination. With the combination of the identifiers that we utilize in the LoRa standard, we use an application ID, a device ID, and a network ID. So you know that it's a trusted device, you know that it's a trusted application and a trusted network. So it's important that you craft your design for any IoT deployment in a very secure fashion, and we bring all of those capabilities to the table. But for metering, absolutely, that's something for utility, both power and water, are applications we're working on today. So lots of other key attributes here. Ultimately, what's really important here, you have great security, you have great price points, and you have very, very strong distance out of your LPWA solution. So a little bit about the LoRa Alliance. So the LoRa Alliance is a technology alliance. It is the fastest growing technology alliance right now in the world. 400 members strong. You can see the group of global companies that are part of this technology alliance. So this is really intended to help standardize low power wide area network. It's an area, there's lots of different types of custom LPWAs out there, proprietary private low power wide area network solutions. LoRa is intended to really bring us standards to this, to make really a pervasive approach that's simple, global within the LPWA space. We've been a very strong supporter of the LoRa Alliance. I mentioned before, our CTO, our CEO are active participants and channel leads, they are committee leads for several of the key committees that we have within the LoRa Alliance. Very important that you have a standard. LoRa it's kind of new here in the States. It's actually been developing within Europe, within Asia. So companies like Orange Communications have rolled out a nationwide network in France. SK Telecom has rolled out nationwide within Korea. We just had SoftBank announce their support. They're rolling out a LoRa network nationwide for Japan. In the United States, it's been a lot slower. The telcos here are very big, and they've been helping slow down some of the adoption of other technologies with things like LTE, M, and also NB-IoT. So LoRa is really rolling out. We're the first ones rolling out here. Comcast is a very big service provider which has announced support for LoRa. They're building out network in both Philly and San Francisco. And we're partnering with all these guys. It's important that you have a very simple, standards-based solution for sensors that can work wherever. You take your sensor from New England to California, just like the 3G, 4G standards, it'll work wherever you are. That's really what LoRa provides. It's really a global standard that'll work even flying over to other countries. You can reprogram the data rate and the ISM bands it operates in to be able to operate within local area countries as well. What Senet does in this space, we really have three key pillars to our solution. But it's really important that you have an IoT ecosystem. And we are really focused on obviously building a network, having a very low cost, very simple application, very easy onboarding process to our potential customers. It's really important that they can have a seamless experience, both inter and intra-networking roaming, really important. This is something that mobility in the world of IoT isn't necessarily always the first thought, especially for applications such as we have, which is tank monitoring. Tanks don't move around. But certainly applications like asset tracking, very, very pervasive application across multiple industries. You really need a very advanced mobile network architecture that allows you to participate in those type of applications seamlessly, securely. And that's one of the things our network does, really built on our network server. So this is the software engine that runs the LoRa network for us. So LoRa is a centralized architecture by nature. So it's very similar to software-defined networking. So centralized architecture, which allows you to very, very simply scale the network very, very quickly. And again, that scalability provides very, very, very cost-effective capabilities to scale for large enterprises, for large service providers, which is really important. When you think about IoT, you think about, again, you're expanding someone's business. They used to have 100 data points. Now they have thousands of data points, hundreds of thousands of data points, maybe millions. At that point, you need to be thinking about fractions of a penny. What is the cost of my transport layer? What's the cost of my device? Really, really important as you get to that million scale. Pennies count, dollars count. And when you have a scalable platform that we have, you get a very, very effective cost transport layer all the way through the entire value chain of the solution. So something we very much focus on, kind of our core IP, is within our software, the ability to very, very inexpensively provide a network service that's very scalable, enterprise-grade, carrier-grade to the world of IoT. From an operations perspective, we have a very customer-specific and mapping set of tools we've developed, and we use some third-party tools to be able to provide very quick development and deployment of our network. Our devices, we put them up on towers, just like the cell companies. We'll put them on building tops in cities, just like cellular companies. The difference is our gateway is about the size of a shoebox. We have you've seen, if you drive around, you see cellular arrays up on towers, the big directional multi-panel arrays, very expensive. Lots of significant weight they apply on the towers. Ours is the size of a shoebox with a single omnidirectional antenna, a 5-foot bipole antenna. Physics is on our side. When you think about the economics of a deployment, the equivalent of renting tower space, the equivalent of cost is compared to a building is square footage. So you rent on a tower by how much structure load you take up, because that's what defines how much they can put on that tower before it falls over. It's actually been a really important element. Many states have actually have taken back their requirements or constrained their requirements on structure load because of some aging infrastructure challenges in some states. So very, very small. We can actually deploy network within 6 to 10 weeks. From not knowing where we're going to having a customer engaged, I want network in Boxborough, Mass, we can be up there typically within 6 to 10 weeks. The industry average for a carrier type of a network deployment is 6 to 9 months. So it's significantly faster. Really important that we can then work with our application partners to be able to deploy an open air network very, very quickly. We have 3 different types of gateways we can deploy, and we have deployments now for smart building applications that really are rooftop and in-building gateways as well. They'd be part of a secure IT infrastructure and data closets, and again, we work with our customers to ensure that fits the security protocols and the application protocols for that particular enterprise. But very, very lots of details. And one of the really nice parts with our tools and having an open spectrum is it's free. So you can really mitigate a tremendous amount of cost by using that free spectrum. So what's the concern in that free spectrum? It's noisy. Lots of people try to use that free spectrum. Absolutely true. What's really interesting with LoRa has several key capabilities. One's called adaptive data rate. And what LoRa can do is look at, and what we do as Senet is we actually provide, our tools provide us a 24-hour, a 12-hour, 24-hour view and trending statistics on every channel across that open spectrum. So we can actually program and adaptively adapt different data rates for our end devices so they can maximize battery life and maximize quality of transmission. So really important to have that level of telemetry within your systems. That's one of the key tools we utilize within the LoRa standard, within the Senet operations to optimize our customers' experience. I talked about some of this, so I won't get into too much detail. You see our network deployment there. We have almost a contiguous network from the mid-coast Maine down through Philadelphia. We have, as I mentioned before, 225 municipalities, most of the top 10 cities, I think all but one, most of the top 15 cities in the country. We have been focusing the network deployment for the last year on two things: on some land grabs, which everyone's trying to do, but also on revenue-generating applications. We have a revenue-generating application that I'll talk to you about in the next slide, but there are some really significant opportunities with scale and space that our network really does provide. I meant you see here 10 to 20 miles, 2 to 5 miles on urban. We've got some very, very unique use cases that can get tremendous distance. And again, we have devices reporting in with 99% packet success rates in areas like California at 67, 70 miles. And again, we don't design networks for that type of distance, but it allows you a tremendous level of resiliency and redundancy built into your network overall. One of the unique differentiators with LoRa as well is LoRa has a protocol has a very, very tight timing specification on its radio chip. So it has the capability with triangulation to be able to, without the cost of the GPS componentry, to actually do geolocation. That's one of the really interesting selling points with LoRa. You can actually geolocate devices with triangulation on the network. It's one of the areas that's really starting to roll out. They launched that standard not too long ago on how that works on 8/16 channel gateway. We are working and supporting that standard, and it's a really important development where now, again, the cost of that componentry at $3, $4, $5, $10, depending on volumes, is important. We're talking about millions of devices. So that's a really unique differentiator for LoRa. Senet's network, again, we're the biggest in North America. We have a series of different gateways that we deploy networks from 64-channel, 8-channel, and single-channel devices. These are deployed across again, 23 states. We have the ability to go very, very quickly. We've doubled our network in 2016. We're actually going to triple our network in 2017. So we're actively going after and building out applications on our network with an Accelerator Lab. So this is actually something we call our Senet Foundry, but this is an Accelerator Lab. We have a lab right here at our headquarters in Portsmouth, New Hampshire. We are opening up a lab in Silicon Valley as well. And this is really to provide an onboarding path for our customers. We've taken about 50 customers through this process to date. What this really is, it is a classroom-style training. We walk them through the standard. We provide the firmware. We provide development kits. We provide them really the expertise that we have gained over the last 2 years operating and running a LoRa application. We provide them a network sandbox, so they have the tools to be able to come into our network locally or where they are with a small microcell. They can connect to their lab network or one of our production network environments. Can connect to the network, register devices, do their testing, and come out with an application that's ready to go into the certification process. We will certainly help them through the process of certification. That's not only that's the LoRaWAN certification as well as regulatory certifications. Really important that you have an onboarding ecosystem within the space because it is so new. It is a service that we offer up, and we've had, again, a number of really big companies to really small startups take us up on this service. But it's important to onboard and so you guys can get your applications to market as quick as possible. So from an energy perspective, I want to talk a bit about EnterTrack. EnterTrack is actually an application that is how Senet started. So EnterTrack started in 2008. We consider it is a production ready application. We manage EnterTrack as a separate standalone company. EnterTrack started in 2008, and it is a tank monitoring solution, and we call it tank automation, where now you're not just looking at several of your really important tanks for commercial accounts, for maybe your bulk storage facilities. Now you can take that for that same price point that you may buy 100, you can buy 1,000. I'll give you an example of the price points here. I think it's telling from this perspective. Right now, there is no other LPWA solution in the tank monitoring space. The devices EnterTrack sells are $40 for the end nodes. And to be honest, we think we could actually get it even cheaper than that. We have a next generation device, which we're hoping to be half that cost. Right now, the most cost-effective cellular solution is based, so the rest is all cellular, is about $160 list price, and most are in that $200 to $300 range. So when EnterTrack came to this market, they really disrupted the market with something that is at a minimum 3, but in some cases 10 times cheaper than the existing technology in the market. Data rates $2 to $3, depending on volume, per month for storage, and that includes the data services on the analytics engines that we provide in the space. Ultimately, this application competes with technologies that we're charging $10 to $15 to $20 a month for the same level of service. So again, multiplier of 2, 3, 5, 10 times cheaper to deploy. So this is a real proof of concept for low power wide area network. We have 30,000 of these devices, a little bit north of that, now deployed with LoRa throughout the United States. Some customers that we have from regional energy marketers through national brands. How it works, so very, very simple. This is the Senet network that we utilize in the middle here, our network server, the application routers, data storage services. We stream that data to RESTful APIs to a hosted cloud application you see here that is really connected to the ERP systems of the fuel and energy marketers. And what this allows them to do is allows them not just to know what's in that tank and be able to manage runouts, because that's the cardinal sin in energy delivery. You don't want your customers to run out. They can now optimize their truck deployments. So they can now optimize routing. And I'll go through some numbers on the next slide, but we've seen customers that are seeing 30% plus savings on their routing when they have deployments at scale deployed. And we have one customer, they have about 10,000 of the LoRa WAN devices. We had a previous technology, still about 10,000 of those deployed, so 20,000 devices on a network that on an overall tank population of about 35,000. So they have 2/3 of their devices under coverage, under monitor. That allows them to be extremely efficient. This is a customer we have in California. They do a lot of, they do some heating, propane delivery in California, but a lot of it's actually agricultural. And if you've been to Central Valley, California, you know it is a massive farming area with mega farms. You can drive down the highway and be going by the same farm for 20 minutes. They are absolutely huge. So the amount of propane for crop drying, for agriculture applications, for pivot irrigation systems, very important to keep those systems operational. They utilize our technology to do that. 2 types of sensors, one direct read, one a remote read sensor. This is a real live application happening today at a price point that's about 1/10 of the industry standard using standard cellular connections. Some of the details behind this I think are important. I mentioned 30%. For these trucks to deliver in general, it ranges depending on who you talk to, whether it's a big distributor in California, whether it's a local regional delivery marketer. Ranges anywhere from $50 every time they pull the e-brake to we've heard as high as $137. We've done some studies. We think the average is somewhere around $70 to $75 every time they pull that e-brake. So if you think about what they can save from $1, a single trip saved for one tank in a year, you get to pay the entire ROIs within that first year. That includes your cost of hardware and your cost of data. There's nothing else in the market that can do that. But we state as little as 2 deliveries. 2 deliveries, you should be putting back a couple $100 in your pocket at a minimum. And our cost for the first year is $75. And we signed 5-year contracts with our customers, so the next year they're just paying the $25 to $30 for data fees, and they're seeing significant savings. Reduce wear and tear in their trucks, reduce CO2 emissions, tremendous value not only to them but to the customers. One of the really important elements of this is customer service, and our customers now changing the way they do business. When you have the data from thousands of endpoints, you can really optimize the way you engage with your customers in a way that you never thought before. We have one of our customers here in Rhode Island. Every time there's a storm coming up the East Coast, they send practically automatically, there's a little bit of manual intervention, but a proactive notification to all the generator accounts. These are expensive homes on the coast of Rhode Island and Connecticut. Dear Mrs. So-and-so, just want to let you know, you've got your generators topped off, you're in great shape, we just want to know that we care. Or, Mr. So-and-so, we realize you're about 40%, please can we come over and get your schedule before the storm? So they can proactively manage their business, their inventory, and their customer service in a tremendous way. And in that particular business, your customer acquisition costs tremendously high, customer retention, one of the most important things you can provide. Our systems really allow that. So a lot of really cool things you can do from that perspective with data. And this is what we do with our customers. We ask, and this is not just for energy monitoring, any industry, we say, how can you do your business differently? We allow you to think about the way you do business now in a different way. What can you do with 1,000 more data points on your network? And people start getting their ideas. They usually come with an application. We ask them, what do you think you can do more? What else do you really care about in that space? Is there an application we can connect you with in that space? So in that vein, Senet is really focused on several core vertical markets. And I mentioned it really falls into oil and gas, vertical, the EnterTrack solution I just mentioned. But there are several other core markets we're making a lot of really great headway in: smart agriculture and farming, from crop sensing to soil moisture monitoring. These are great open air coverage models where you don't want to send people. You want a battery that's going to last for 10 years, and you want that device, instead of having 100 crop sensors or soil moisture monitoring sensors over your 100 acres, you like to have 10,000. So your ability to now precision irrigate and save and conserve water, save and conserve energy, tremendously higher. Okay, question?
How about building automation systems within buildings? That's where we spend a lot of time.
Yeah, absolutely. So that's really the smart building, management. So there's absolutely a lot of different projects we've been working on in that space as well. And so one of the unique things with LoRa, it's bi-directional. So you can actuate, not only communicate, but actually actuate and provide, again, very, very inexpensive cost connectivity solution for in-building sensors. So we have customers that we're working on for smart building for temperature monitoring. We have smart building monitoring for smoke detection with some hotels. They want to know that people are smoking in different areas of the building. Noise monitoring is an important one for hotel chains that we're working with. These are little small noise tags they can literally stick up on a wall next to their executive suites, conference spaces, and determine, is there actually a noise problem in that area? Do we need to send a security guard? So those are some applications on the building management front. There are LoRa applications right now that are coming here to the US for smoke detection, CO2 detection, actuators for HVAC systems, for skylight operation. So there are solutions right now that are available today utilizing LoRa in the building management space. Ours have been more focused on specific verticals, mostly in hospitality and some data center services for refrigeration and temperature monitoring within buildings. But there are a lot of applications today. That's one of the benefits of the Alliance. The Alliance is 400 companies strong. There are applications all over the world that are available to us. We can provide and connect companies with different applications that again, we just want people to use our network. And we are offering that network solution to be able to connect the two together. But we have a rich history. If you go online to the LoRa Alliance, you can actually download a catalog so you can see the applications that are there today. So I'd recommend if you Google LoRa Alliance, or we can certainly have pointers to it on the Senet website. Again, this is important. We closely work with third parties that really across the value chain that have these applications available and ready. And it's important. Around building management, it's certainly a big one. It's one of the key areas that we know there's a lot of focus. We're just hiring right now a biz dev director to really help drive our smart building approach. But there are a lot of applications. We're engaged with several beta and alpha rollouts right now.
So you had mentioned the EnterTrack was mostly propane. Is that spreading into fuel oil?
It's fuel oil as well. So I gave you a couple of examples of propane, but it is actually fuel oil as well. I didn't spend a lot of time on those specific sensors. This is a direct read fuel oil solution that is used for smart buildings as well. So this is actually certified to be used on number 2, number 4 heating oil. So some of the big industrial furnaces down in New York City, some big cities are still using number 4 oil. It's a very thick, sludgy, heavy heating fuel. Certified for that, gasoline, diesel. Most of the devices we have deployed for this technology are either in 275 home heating tanks here in New England, which is, they don't use a lot of heating. They don't use oil for heating really outside New England. It's all propane in the rest of the country, which I didn't know. I'm new to that industry, so that's something I learned. But diesel skid tanks on farms is a really big application. Diesel tanks for generators as well for smart buildings. This is a technology can be used for that as well. It's a direct read device here. It's a capacitance sensor that goes down into the tank and monitors really the open air level. It's a capacitance reading on the metal tank. Very effective, very cost effective. This is how EnterTrack got started, by the way. They patented that technology, and that was really, again, a really neat innovation in the industry. It's still the most cost-effective sensing solution. If you look at other solutions such as pressure differential sensors or ultrasonic, you're paying a premium for a lot of those technologies. Very, very cost-effective, actually very accurate. Yes?
If you deploy in a city, is it your technicians that are installing the devices, or a building automation system level tech, or just a maintenance person that's doing the installations?
Yep, so great question. So we use third-party installation. So we're a small company. So we use all third-party site acquisition installation firms. These are all certified installation teams from regional. We have regional teams that cover our technology. We can work with your teams if you wanted to get certified and trained up on that process. It's not difficult to install the microcells. The macrocells are a little more involved. These are typically installed up on towers and require climbing certifications. You have to be certified with big companies like American Tower Company and others. But the microcells can be deployed by any technician, as long as you go through a quick certification program with us. Yes.
You say this product has a short payback. Is this short payback when you put a product on an existing network, or let's say if you are trying to put it on an area where there is no existing network?
Yeah.
Then how does it vary, the cost in those two scenarios?
So what we do is we will design the network for the application. So we would put up a network for really the density that's required by the end customer. If they want to have 1,000 devices over 100 square miles, that's a certain type of network design. If they have a very dense neighborhood or building where they want to have deployment, we would design the network effectively for that. And that's a combination of the three different technologies we talked about, which is a macrocell, a microcell, and a picocell solution. Picocell is a very small indoor solution that was really meant for smart home type of applications, but could be used for smart building as well. Yeah.
So if I say mesh network and Tropos, where do you fit in with that?
So this is really kind of a star of stars network architecture. So we have an end device that reports into our gateway, which funnels back to a centralized server. So it's not really a mesh network from a topology perspective. It's kind of a star of stars architecture. But it competes with other mesh technologies. Again, mesh is very interesting from a redundancy perspective. One of the things that we have in network resiliency, reliability, this is my background, and one of the things, it's all about the design. It's really about how you're planning redundancy at the gateway, at the end node, and at the backhaul system for these type of networks. So in the stars, we find extremely high availability capabilities.
You compete with mesh networks, and you have unis and police departments communicating over this network.
Yep, it's great question. So absolutely. So they utilize that ISM band for sure. One of the things, and typically it really depends on how they're deployed. So what we do is obviously we do our studies every time we go and deploy a network. So we look at what is deployed in those areas. We only really use commercialized assets where there's a pretty good record of what's deployed from our perspective, because that is important. And which we try to avoid, depending on where they are. If it's an emergency response beacon, we'll make sure we try to avoid that. If you have point-to-point microwave, we have to make sure we have some distance from those microwave receivers on the towers. But we plan around the RF side of that. But there's a lot of capability in that ISM band. There's a lot of bandwidth there, and a lot of times it's just not used very much. And it varies from space to space. It varies from the city to the countryside. There are significant variations if you look at where you are in the country. But certainly there's a lot of open bandwidth there. And one of the really great elements of LoRa is the ability to mitigate noise and be able to program effectively, adapt to different channels based on the noise level. Yes?
Are you able to rebroadcast inside a building, or is that?
To rebroadcast?
Yeah. It's like, say you,
Yeah.
this whole steel thing's kind of more, I'm just wondering how that should work. So if one of the solutions of maybe you have the capability to rebroadcast a signal inside.
Yeah. So if you were really, and we have to take a look at the details of the structure. Again, we have a lot of building applications we utilize. So I want to take a quick look at the architecture and the structure that you're trying to deploy. But what we can do is we can deploy a microcell inside that cage effectively. So you may not use our open air network up on towers. We'd have a microcell deployed in your building to be able to get around that type of environment. If you really had a very hardened, metal structure that wouldn't allow noise, wouldn't allow signal in and out. We find there's ways to get in and out. And I've been shocked how well you can penetrate some structures that you think are practically impenetrable from our perspective. How are we doing on time? Okay.
Have you done any applications with military bases or banking entities yet?
We have not. No.
Is there any obstacles there that you?
So what I mean, a lot of those companies are choosing to do private networks. So we're a public network provider.
Yeah.
We can do semi-private networks. It's something that we do offer up to our customers. But some of those, for security reasons, it's easier for them to do a fully private network. And there's a mindset that really is more secure. And again, if you're talking about the structure of your local area and wide area network design within your enterprise, then you can mind the ability for it really won't make a difference whether it's private or a fully public network utilizing our technology. But the key with private is that's how people have been doing this business for quite some time. So a lot of companies have been doing their own private networks for the last 10 or 15 years, utilizing ISM band, utilizing a custom LPWA type of a solution. What they realize is that that's not the core capability. That's not the core value proposition for their customers. They don't want to run a network. They'd rather build a great water meter. They'd rather build a really great building automation system and utilize another network that's out there and capable. And again, the real mindset is, cellular is public, available. People, banks, governments operate on those type of networks today. We're doing it really now, similar format, but for machines. So, question?
Have we gotten through your slides?
I think that was it. The last one, I think
I want to make sure we get through all of your presentations.
and that was it. So I'll be here all morning, guys. If you have any questions, feel free. I'll give you a business card. We can set up a discussion. A lot here, a lot of details behind this. We've really touched on scratched the surface here. So please, if you do have any questions, I'll be here all morning. We can chat some more.
Great.
Thank you.
That's all.